Hi all, I am here with my new video on chapter 9 acids and bases. Let's start. In this video we will learn about pH, pOH and hydrolysis. pH value to determine acidity or basicity of a solution. We note that in every case Kw is equal to concentration of hydronium ion multiplied by concentration of hydroxide ion, which is equal to 1 into 10 power minus 14. We don't need to know both concentration of hydronium ion and hydroxide ion in order to determine how acidic and basic a solution is. Either one will do. We can use concentration of hydronium ion or exponent of the hydronium ion concentration, which we call pH. We can also use the exponent of hydroxide ion concentration to develop a pOH scale that runs from 14 to 0. A pOH less than 7 indicates a basic solution. The lower the pOH below 7, the more basic the solution. A pOH greater than 7 indicates an acidic solution. The higher the pOH above 7, the more acidic the solution. One change of 1 pH unit represents a tenfold change in the hydroxide ion concentration of the solution. Relation between pH and pOH. pH plus pOH is equal to 14. General definition of pH and pOH. The general definition of pH and pOH, which can be used for any aqueous solution, are as follows. Hydrolysis of salts in aqueous solutions. When we taste the aqueous solution of NaCl, we find that its pH is 7. However, not all salts produce neutral solutions when dissolved in water. Some salts such as NH4Cl produces an acidic solution, and some salts such as K2CO3 produces a basic solution. Let us analyze why the salt produced by the interaction of a strong acid and a weak base produces an acidic solution when we dissolve in water. The salt NH4Cl is produced by the reaction of HCl, which is a strong acid, and NH3, which is a weak base. When this salt is dissolved in water, NH4 plus and Cl minus ions are present. When we examine the conjugate acid-base pairs, we find that the chlorine ion is weaker base in a molecule of H2O. Therefore, chlorine ions have no tendency to accept protons from water molecules, and no hydroxide ions will be produced in the solution. The NH4 plus ion is a stronger acid than a molecule of H2O. Therefore, NH4 plus ions can donate protons to water molecules, and additional hydronium ions will be produced in the solution. As a result, the solution contains a slight excess of H3O plus ions and is acidic. Hydrolysis definition. We call this process on which NH4 plus ion interact with H2O molecules hydrolysis, and we say that ions hydrolyze in water but chlorine ion do not. Using this analysis, we can conclude that any combination of strong acid and a weak base will produce a salt whose aqueous solution is acidic. We can do similar analysis for salts that form from the interaction of a weak acid and a strong base. The salt, sodium acetate, is formed from the interaction of acetic acid and a strong base NaOH. In aqueous solution, Na plus and C2H3O2 minus ions are present. A Na plus ion will not hydrolyze because it is neither a conjugate acid nor a conjugate base. However, C2H3O2 minus ion is a stronger base than water molecule. C2H3O2 minus ions will hydrolyze in water by accepting protons from H2 molecules, and additional OH minus ions will be produced in the solution. As a result, the solution contains excess of OH minus ions and is basic. Using this result, we can predict that any combination of weak acid and strong base will produce a salt whose aqueous solution is base. Acid-base properties of oxides. Certain oxides can combine directly with water to produce an acid or base. The metallic oxides of group 1 and 2 form bases. Such substances are called basic oxides. The non-metallic oxides of group 14, 15, 16 and 17 form acids. Such substances are called acidic oxides.